Television has been growing in popularity as a means of investigating the condition of all types of buried sewer lines. As an investigative tool, it is unmatched. The advent of television inspection has enabled operators to pinpoint structural damage, corrosion, leaking joints, root penetration, illegal connections, and other problems often seen in older lines. Maintenance and rehabilitation of older systems has been made possible through the use of televised inspection. And as the older lines are brought up to today's standards, much of the credit is due to underground television surveys and to the fine work of the crews that do the evaluation. More recently, however, a number of agencies are using television as a means of determining the acceptability of newly constructed lines. Opinions regarding structural damage are, in many instances, made erroneously. Operators of television equipment are looking for problems. This is the nature of their job. However, there have been many instances where dig-ups have shown the problem described in the log to be either non-existent or of a significantly less magnitude than originally indicated. Unfortunately, when entered into the operator's log, these unintentional errors of judgment have frequently led to conclusions which become difficult to resolve. This practice has resulted in delay, extra cost, confusion, and in some cases, legal action. To prevent unnecessary expense, delay, and possible litigation, the National Clay Pipe Institute and the National Association of Sewer Service Companies agreed to co-sponsor a project to explore these problems in greater detail. Recognizing the educational benefit that would come from the study, the Hughes Corporation also agreed to participate. The evaluation would be done at the clay pipe manufacturing facility of Gladding McBean, located in Lincoln, California. The goal of the project is to demonstrate and identify several factory and field conditions which can be erroneously interpreted during televised video inspection and assessment of new sewer lines. It is by no means all-inclusive, as many other conditions may be found in a sewer. The following three areas will be covered. 1. Sags in line. 2. Seeing is believing. Or is it? 3. Perceived defects. Sags in line. The first test shows a simulated sag in an 8-inch clay pipeline. Although the amount of sag permitted in a pipeline is not specified in ASTM, it is common knowledge that all pipelines experience some settlement under load, and it is due to the pipe bedding rather than the pipe itself. It should also be noted that a televised inspection made shortly after a water exfiltration test can have the appearance of a sag due to the standing water, which may take a long time to drain from the line. This is especially true in a line with a very flat grade. Such lines have been erroneously declared to be leaking by an inexperienced operator. Estimating the depth of water is very difficult. Can you estimate the depth of water in this pipe? Visually, there is no point of dimensional reference other than the pipe itself. Our measurement indicates the water depth to be 1 1/2 inches. Seeing is believing, or is it? The next part of the evaluation was done in 2 short lengths of 8-inch vitrified clay pipe. The shorter lengths were selected for ease of setup and adjustment. The pipe were without joints of any kind to enable maximum joint movement. A frequently observed field observation is sometimes referred to as a halo. It was believed to be caused by the camera light reflecting off the pipe, especially at the joint. This reflected light tends to exaggerate and distort the resulting image. Let's listen to an operator's comments.
What you're now viewing is a 1/4 inch. The upstream section of pipe has been raised a 1/4 of an inch higher than the downstream section. As we turn the iris up, you can see the top of the pipe. The offset that you would see would be in quadrant 3, which is the top of the pipe. You would not see anything on the bottom when the upstream section is raised.
The camera used by Q's at the Lincoln tests was a current model, which had automatic light and lens adjustment capability. This time, when the operator attempted to increase the light intensity, the camera lens simply compensated for every light adjustment. Unable to reproduce an often observed field condition, the Q's engineer was asked to disarm the automatic light compensating feature and go to a fixed light system. When these modifications were made, the condition observed in the field was immediately duplicated in the test setup. Using both the auto and fixed light arrangement, a series of tests were made in several conditions. Straight alignment. This is the joint in straight alignment. With the camera set at a slight angle relative to the center line of the pipe, notice the appearance of the right side of the pipe. This is due to the slight taper, which is a result of factory trimming before the pipe is fired. The other side also has a taper, and although it is only slightly smaller, it is not accentuated by the camera. Here is the same pipe with normal light and the joint taken apart. Notice as the light changes, the taper becomes less visible. With the camera placed back in the pipe, notice the difference between the auto-adjust light and the fixed light. Pulled joint. The next tests were of a pulled joint, which is sometimes called a gap between the ends of the pipe in straight alignment. Gaps of 1/16, 1/8, 1/4, and 3/8 of an inch were simulated between the pipe ends to create the gap. Notice that the full circumference is visible, which is an indication of a pulled joint. With the gap set at 3/8 of an inch, notice the change in appearance when the intensity of the light is increased. Keep in mind that the pipe is still in straight alignment and there is no offset. The clue to determining whether it is a gap or an offset can be found by looking at the joint. A gap should appear uniform around the pipe, but an offset will be crescent-shaped. The position of the lights can change the appearance, making interpretation difficult at times. Parallel offset. The next series is a parallel offset joint. By the use of pipe supports and shims of varying thicknesses, offsets of 1/16, 1/8, and 1/4 of an inch could be simulated. When one pipe is displaced in a parallel manner in the amount of 1/4 of an inch, the joint looks like this. Notice the distortion when the light intensity is increased. Doesn't this offset look more than 1/4 of an inch? Angular deflection. The next series is angular deflection. ASTM standards require clay pipe joints to seal in angular deflection up to a minimum of 1/2 inch per foot of length, depending on the pipe diameter. Although harmless in the normal operation of the sewer, the edge of the pipe can appear as a gap, and it could be noted as such by the operator. Although there may be a gap on one side due to the angular deflection of the pipe, the other side of the pipe is completely tight, as demonstrated by rotating the pan and tilt camera around both sides of the joint. The following view with normal and high light intensity is well within the sealing range of factory-applied joints and the allowable limits of the ASTM standards. In fact, there is nothing improper about this condition. and if the line otherwise meets a pressurized air or water test, it is completely acceptable. Perceived defects. With the camera still looking at the joint in angular deflection, we will increase the light intensity. Notice that the two areas merge together to give the appearance of the end of the pipe. As the camera moves in for a closer view, it becomes obvious that there is a tapered surface on the inside of the barrel that is reflecting light and contributing to the visual distortion. To understand this condition, it is necessary to look at the manufacture of clay pipe in some detail. Following extrusion, the ends of the pipe are cut to length and trimmed to remove excess material. End finishing is done with sharp rotating knives that produce a very slight taper on the inside edges of the barrel at each end of the pipe. These tapered areas are almost invisible to the naked eye, but when the light is reflected off the surface and the camera is in the right position, the taper can appear to be a gap or an offset joint. There are other conditions which can be misinterpreted. Manufacturing marks, surface scrapes, and forklift marks can give the appearance of cracks or fractures to the untrained inspector and can lead to erroneous and costly interpretations. Summary. 1. The image as seen by the eye of the camera can be distorted. The appearance of an offset joint is exaggerated by any gap between pipe ends and the angle of the joint itself. 2. The camera angle increases the distortion. A camera that is not centered in the pipe will allow the camera eye to look into a joint rather than along the interior pipe surface. This distorts the operator's perspective and consequently the interpretation. 3. The specific dimension of an offset, a joint gap, or the depth of water is limited in accuracy. 4. The operator's log is frequently interpreted as being much more accurate than the operator intended. 5. Manufacturing and handling marks can appear to be serious defects. The brightness of the light will influence and distort the visual image. As we once again look at the exaggerated reflection off the tapered edge of this pipe, we are reminded that as an acceptance test, the interpretation of television inspection has not reached the level of reliability or accuracy demonstrated by established ASTM acceptance tests. Television inspection is a good tool. Let's not ruin its effectiveness by exceeding its capabilities. Simply stated, you've got to know your limitations.